Hey guys, today we are doing the last piece of Unit 3, which is to find compositions. So today we're going to be simplifying composite trig expressions that contain ratios, angles, or variables. There's two things we need to remind ourselves of, and the first one is our lovely SOHCAHTOA, so we can find those trig ratios. And the other thing to remember is PEMDAS, and when we use PEMDAS, we always work from the inside out. So we're going to try the inside of whatever I have, and then we're going to go ahead and work through the outside. So the first type of composition you're going to see is one where they give you a ratio on the inside. So they give you an inverse trig function and then a ratio. This right here is simply asking us to find some angle. We want to know what's the angle that has the sign of 5/7. So when they just give you a ratio in here, the first thing you're going to try to do is draw a triangle. And so, since I know that this is an inverse trig function and that this is a positive value in here, if I think about my restricted range for sine, I would know that that positive sine value is going to be over here in the first quadrant. So here's that angle that has this guy. I'm going to use my SOHCAHTOA and know that sine is opposite over hypotenuse. And then I can go ahead and use the Pythagorean theorem to find that last side. So I'm going to call this side x, and I'm going to do x squared plus 5 squared will give me 7 squared. And again, this is just a solving of the Pythagorean theorem. So I would have x squared equals 49 minus 25, which is 24. So x alone would be the square root of 24. I can simplify that down using simplifying radicals. I know that this is 4 times 6. So 2 times the square root of 6 would be that simplified down. So what I've done here, technically I don't know this angle. This is not a 30/60/90, this is not a 45/45/90. So I can't find that angle without a calculator. So I have found the triangle though that would correspond to this angle. So now what I'm going to go back and do is find the secant of that. So the secant of this angle, theta, is going to be the same thing. Remember, secant is the opposite of cosine. So we're going to find your hypotenuse over your adjacent side, which we just found. And so my hypotenuse was 7. My adjacent was 2 root 6, or square root of 24. Remember, I don't have to rationalize that denominator. So my answer would be 7 over 2 times the square root of 6. So if you don't have an inverse on the outside, all you're looking for is some ratio. Okay, again, if you don't have an inverse on the outside, you're looking for a ratio. And if you can't find the angle without using a calculator, then you're just going to go ahead and leave it as a ratio and give me my new ratio of that angle. Okay, I'm going to give you a practice problem if you would like to try it on your own. Try this one, cotangent of arc secant. Now, arc secant is the same thing as saying inverse secant. Okay, just like if you had arc sine or arc cosine or whatever, it's the same thing for inverse. I don't know why I wrote cosine. Ignore that. Okay, sine inverse. So arc and -1 and to the -1 are the same idea. Arc is kind of like the inverse. So remember, your first step on this one is to draw that triangle that has this ratio. Okay, so draw your triangle. Then your second step is to find the missing side. Your third step is to go ahead and find your new ratio, remembering your SOHCAHTOA. Okay, so go ahead and pause here. See if you can draw out your triangle, remembering this is negative and secant goes with cosine. And I'm going to give you the answer, so I hope you've paused. The answer for this guy should be -2 over the square root of 5. Or if you had square root of 5, or sorry, -2 square root of 5 over 5. Okay? The next type of composition you're going to see is one where they put an angle in here. So if you notice, you have your inverse function on the outside. So this right here is going to force me to find an exact value or a ratio. And then I'm going to have to go back and find the other exact value. So my first step here is to figure out what exactly is the sine of 4 pi over 3. So I'm going to draw my angle in. Well, yeah, I don't do straight lines very well. We've already learned this. So 4 pi over 3. If you don't know your unit circle, you can still do that trick we had where this is 0. if this guy is pi, that's the same thing if I put it in the common denominator of 3 pi over 3. This guy over here would be then 6 pi over 3 to get to 360 or 2 pi. And so halfway in between that would be 4.5 pi over 3. So I know that 4 pi over 3 is in between these two guys. So my angle would be right here. So that is my 4 pi over 3 angle. And if I go ahead and find the reference angle there, remember I want to only know this piece right here. In order to find that reference angle, I'm going to take 3 pi over 3. Well, maybe 3 pi over 3 and subtract it from 4 pi over 3 because 4 pi over 3 is bigger than pi. So that would get me pi over 3. My reference angle is 3 pi over 3 or 60 degrees. Okay. So if I know 60 degrees, I can fill in my ratios. We know that my hypotenuse is 2. Opposite that is going to be root 3. Since I'm in quadrant 3, it'll be negative. And then my adjacent is negative 1. And now I can go ahead and find that trig value. So the sign of this will be opposite over hypotenuse. So I've simplified my inside, and I've found that it's negative square root of 3 over 2. Okay, now this should look very similar to what we were doing with the principal inverse values. I want to find the value or the angle where the inverse cosine is negative root 3 over 2. So now I'm going to have to redraw my triangle. And I know this seems like a lot of work, but we're going to redraw my triangle, remembering that I'm negative and I'm dealing with cosine. So cosine, inverse cosine being negative means I'm in between 0 and pi. So right over here, my angle would be in quadrant 2 is where my principal inverse value would be. I have that this hypotenuse would be 2. The adjacent side would be root 3, which would make this last side 1, which we know then is a 30-degree angle, or pi over 6. But remember, I want to figure out this value, so I'm going to go ahead and take pi minus pi over 6. So that's 6 pi over 6. So my answer would be 5 pi over 6. So again, on these guys, we've got to first find the exact value, which is going to give me a ratio, and then go back and find that angle. So you're going to have to remember the quadrants of where things are positive and negative, and you're also going to have to remember your restricted ranges for your inverse trig functions. Okay, I'm going to give you another try, this one. Inverse sine of the cosine of 3 pi over 4. Remember, you're going to have to find your inside first, which will give you a ratio. Then you're going to have to go back and draw a different triangle to figure out what that trig value is. Okay, so again, you better pause it. I'm about to tell you the answer. The answer for this one would be negative pi over 4. Okay, and the last type of composition you are going, well, the last type of number composition you're going to see is ones that have those 0, 1s, and undefineds in them. So the first thing that I'm going to do on this one is, again, the inside. Always inside first. So I want to know on this thing, where is tangent 0? You're going to find the tan of 0. So there's a couple ways to do that. You can remember your coordinates and know that tangent is the same thing as the y-coordinate divided by the x-coordinate. And then, so what I'm looking for here is I want 0 over 1. I don't want to be divided by 0. Well, I'm 0 over 1 over here, because this is 1, 0, and I'm 0 over 1 over here. But remember, the restricted range values, or we're just looking for that first one. So the tangent of 0, we could find out was just some number. I don't know why I'm thinking this. This is a degree measurement, technically, or a radian. So we technically just want this guy, and so I know y over x would be 0 over 1, and so the inside of this is 0. Okay, so again, we can also, if you see those zeros and stuff, you can use your OIO chart. Remember, this is SOHCAHTOA, this is 0, 90, 180, 270. But when you're going in here, so this one would have been tangent of 0. So I would have gone to tangent 0, I would have found that it was 0. Okay, but if you're doing an inverse, you have to look inside your function. And so since I'm looking for a cosine of 0, I need to go to my cosine guy and find where I am 0. So I'm 0 right here and right here. Remembering though at my restricted range values, cosine goes from 0 to pi, or 0 to 180, so I'd have to pick this guy because he's in between there. So my final answer for this guy would be pi over 2, or 90 degrees. Because if you have an inverse value, you go inside your chart. If you have just a regular value, just an exact value, you use your tangent 0, 0. Okay? I don't know if I have a try this. I don't have a try this. Okay? Last but not least, and this is the reason this video might be long because I combined 2 days, is we're going to find ones that have variables in them. Oh boy. So these are called variable compositions, where they put an X in instead. And I actually find that these are a little bit more straightforward because you're just drawing triangles. So the first thing, again, you're going to do your inside. I want to draw a triangle that has an inverse cosine of X. So I'm just going to go ahead and draw a triangle. Here's my theta. You can put theta wherever you feel like, just not your 90. Cosine, remember, is adjacent over hypotenuse. So your adjacent side to theta will be X. Remember, if there's no denominator, it's 1. So your hypotenuse is 1. Now I'm going to go ahead and figure out what my last side is. So I'll call this A, for instance. So I'm going to go ahead and use Pythagorean theorem here. So I'll have A squared plus X squared equals 1 squared hypotenuse squared. And I'm just going to solve this guy for A. So I'll subtract X squared from both sides. And 1 squared is just 1. Take the square root of both sides. And I know that my A value then is 1 minus X squared. So now at this point, I just go back and I figure out what are they asking me for. So they want to know the sine of that guy. So sine of theta is going to be your opposite over your hypotenuse. And your opposite here was that crazy square root business. All over your hypotenuse was 1. So your final answer would just have been what that opposite side was. So again, this guy is it's a little bit more straightforward almost, because the first thing you've got to do is draw your triangle, remembering if there's no denominator, it's just 1. You're going to label your sides. You're going to use your Pythagorean theorem in order to find the last side. Be careful which ones they've given you. And then you just find your new trig ratio. So I have a try me question. And on this try me question, we have cosine inverse of tangent of X. So go ahead and try this. Again, pause if you don't want to know, or pause if you don't want to know right now, right now, right now. Again, draw your triangle, and you should have gotten the answer of 1 over the square root of 1 plus X squared. And again, you do not have to rationalize your denominator. Okay, the other types of problems you'll see like this involve numbers, and I just want to point out what's a little different about it. So the first thing, again, work through your inside, draw your triangle. Doesn't matter what quadrant it's in because it's a variable. Tangent, we know, is opposite over adjacent, so that's 1. And then I've got to find that last side. So I'm going to have, who knows what this is over here. So I'm going to have 1 squared plus. Now be really, really careful here. This 3x is all the expression. So if you write this as 3x squared, you're going to miss part of it. Please, please, please put it in parentheses, because technically this is 3x times 3x, which should get you 9x squared, not just 3x squared, not just 9x. It has to be the entire thing squared. Okay, and then I don't know my last side. I'll call it C, because that's, the hypotenuse side. And now I get to solve this guy for C. So again, this is 1 plus 9x squared, because the squared goes to every piece, equals C squared. Take the square root of both sides, and I'd find out that this side is 1 plus 9x squared. Now I'm going to go back and find the secant of that theta. Remembering secant is the opposite of cosine, so it would be hypotenuse over adjacent. Wow, I don't know what I was trying to write there. So your hypotenuse was this crazy thing. Your adjacent side was 1, and so your final answer would just be the square root of 1 plus 9x squared. Okay, it's almost easier when they give you this guy, because then you don't even have to remember that there's a 1 underneath. So go ahead, again, pause right here, pause me right here. and then I'll tell you the answer in a second. Again, draw your triangles, label them, find your use your Pythagorean theorem to find your new side, and then find your new ratio. And so for this guy, you would have gotten the square root of 9 minus x squared all divided by x. And that's all I've got for you. That's all about compositions.